So if you have to calculate the length of the direct common tangent, okay, this, if you see this line here, PT, this line is the direct common tangent to the two circles, right? You have to calculate the length of the direct common tangent. That is, you have to calculate this PT. The length of this PT will give you the length of the direct common tangent, right? Because P and T are both points of contact. From one point of contact to the other point of contact would be the length of the common tangent. And what else is given here? It is given to you that the radii of the two circles are 3 centimeter and 8 centimeter. So that means I will take the radius of this radius BT as 3 centimeter, smaller circle, and the bigger circle, I'll take the radius here as 8 centimeters. Okay. And with the
Good morning, sir.
centers, morning, with the centers 13 centimeter apart. So from here till here, these two centers are 13 centimeter apart. So this length here is 13 centimeter. Okay. Now how to calculate this? See, first of all, what I do is, you see this dotted line. Okay, I draw a perpendicular from the point B. I drop a perpendicular on the radii AP. Okay, so BM, I draw BM perpendicular to AP. Okay, so when I draw BM perpendicular to AP, so therefore PMBT becomes a rectangle. PMBT is a rectangle, right? Now, if PMBT is a rectangle, that means if I simply calculate the length of BM, this must be equal to the length of PT, right? Because opposite sides of a rectangle are equal. Now the question is how to calculate the length of BM. Okay. Now let's see what we have here. See, I have, this is a right angle triangle here, right? Now in this right angle triangle, if you see, the hypotenuse is 13 centimeter, right? This is the hypotenuse. Okay. And this one is your perpendicular, which we need to calculate. And this is your base. This AM, this length here is your base. And what is the base equal to? If you see, this entire length here is 8 centimeter, and this length here is equal to this 3 centimeter, right? That means this length here must be equal to 8 minus 3, which is equal to 5 centimeter. So I know the base as 5 centimeter. I know the hypotenuse as 13 centimeter. From Pythagoras theorem, I can calculate the perpendicular, which will be the required length of the direct common tangent. BM, I can calculate BM square is equal to AB square minus AM square. So I can calculate the length of BM. And once I calculate the length of BM, BM must be equal to PT. Okay. Any question? Fine. We proceed to the next question then. And I have given you a second method also. Okay. So this is by similar triangles. You can attempt this method also. Okay. But that is a more simple method. Question number 7. In the figure given below, ED is a diameter. Okay. So this line here is a diameter to the circle. That means it passes through the center O, right? Of a circle with center O, and AB is a tangent. And this line AB that you see here, this is a tangent to the circle. And what is the point of contact of this tangent? A, right? Okay. C is a point on the circle, on the circle such that DC produced intersects the tangent at B. So C is any point on the circle here such that when I produce DC, okay, it intersects at B. That means it intersects this tangent at B. These two lines intersect at B. Okay. So C is any point. If angle ABC is 50 degrees, so this angle here is given to you as 50 degrees. It is already marked in the question. You need to calculate angle AOC. And let's see which one is the unknown angle that we need to calculate. This is the unknown angle that we need to calculate, AOC. So how do we calculate? It's a very simple problem actually. See, this is the radius, right? This line is the radius, and this is a tangent. And you know radius must be perpendicular to a tangent at the point of contact. So this angle is 90 degree, right? So angle DAB is 90 degree, right? Fine. And what else? If you consider this triangle, ADB, this triangle here, right? This triangle, if you consider, you know this angle to be 90 degree. This angle is 50 degree. You can calculate this angle. What should be this angle? 180 minus 90 minus 50. Because sum of interior angles of a triangle is 180 degree. So this should be 40 degree. So you have calculated this angle, 40 degree. And what you see is this angle is subtended by this arc, right? EC on the remaining part of the circle. What is the angle subtended by the same arc at the center of the circle? This one. So this angle here, angle AOC, the required angle that we need to calculate, this angle must be double of this angle, right? 40 degree. So 2 into 40, which is 80 degree. Okay. So that was as simple as this. Next question. Okay. In this figure, O is the center of the circle, which you can see in the figure, and SP is a tangent. So this line here that is given SP, this is a tangent. If angle SRT is 65, you see already marked in the figure, angle SRT. Okay. Find the values of X, Y, and Z. So given one angle SRT, you need to find out the values of X, Y, and Z. So how will you find? Again, if you see, this is the radius of a circle, and this is a tangent, right? So this angle must be equal to 90 degree, right? So angle OSP is equal to 90 degree, right? Now, once you know this angle to be 90 degree, look at this triangle here. Triangle SRT. This triangle. In this triangle, one angle is 90 degree, the other angle is 65 degree. Then you can obviously calculate X. So X is equal to 180 minus 90. Yes, you can see. Can you hear me?